Hello everyone and welcome to a new video about Raven. In this one again we'll have a look at something we already presented in a previous blog article but we felt was worth highlighting in its own video. So again we're working on this PE parser crash trace where an input PE file is read by the kernel, triggers a bug and then the system crashes. And that file was an output of a fuzzer and with a couple of mutations that we know are necessary for the crash. And so we were able at that point to understand a couple of these locations and the effects of these locations on the crash, but some of these were still a mystery. So at that point what the analysis did, he recorded a new trace with one of these mutations reverted to the original values. So that trace does not trigger a crash. That's the trace we have on the left. We see the tooltip. And on the right is the original trace where the crash happened. And at that point, we want to extract the differences between these two traces to understand what the differences are and maybe have more clues about what's happening. So Raven does not come with an full-blown trace diffing capability, but still here the analysis was able to build something that worked at his scale using the Python API. Basically what he did is create a small script which will connect to the two traces and get at each transition starting from a certain point, get the instructions, and as long as the instructions are equal, it will iterate on that, and as soon as the instructions are different, it's going to stop. That's the script we can execute, but as you know, as you saw, we need to find a first point manually where the two traces are in sync. To do that, we'll try to get as close to the bug as possible. So you're looking at the backtrace. We know that the memcopy is already faulty because we called that with a faulting address, but the closest point where it might make sense to look at is the mi relocate image call. So let's start with that. I'll look for that call on the trace to the left, mi relocate image, and there's only one match, so that's really a point where it's easy for me to synchronize my two traces. Okay, I'm going to assume that the two traces are in sync at this point. And then I'll start that script using the two values of transition number on the left and on the right. And that's what I have here. My script, trace on left, transition on left, trace on the right, and transition on the right. So I run that, and fairly quickly it iterates on all the transitions and find differences. So difference on the left and difference on the right. Okay, if I look at the results, I see that indeed the instructions are different because I took a different branch on the same conditional jump. Because of a difference in the value here, it's 1 and there it's 0. That makes sense. At that point, I probably know where that value is coming from, so I tainted that value that's already set up here. And you see that the two taints have similar results, ZMM, RDX, ZMM, RDX on the right as well, but on the left, something else is tainted. R10 is tainted first, and that's because I have a piece of code here that is executed on the left and not executed on the right, again because of a difference in a conditional jump. So I'll look for that conditional jump's address on the right as well, looking for the execution of an address like so. Again, there's only one match, so for me here it's very easy to know that's the right one, and this is indeed correct. And because here the value is similar, but the value of R9B are different. Okay, so I guess here you get the idea of how it would work with those two traces. Manually, I can sync them up using a script, find a few hints of the differences, and from there, try to work on those two traces and understand the difference. And if you want the details, you can look at the blog article and you see how there he was able to understand the actual effect of that mutation. Okay, so to sum it up, again here Raven does not provide you with a quick answer, but using the automation that you can do with the Python API and some manual analysis, you are able to extract a lot of valuable information and narrow down the locations of code that you have to look at to understand something you're interested in. Okay, I hope you learned something, and as always, thanks for watching.